those of you who don't have an expanded TI, that means a peripheral expansion box in the works. For those who do, there are a few things we're going to talk about today in reference to expanding your TI. Let's say you go over here to Bud Mills table, pick up a nice little SCSI card, stick it in your box, get the thing cranked up, and all you get is a cyan blue screen. But you forgot to remember that you had a Horizon in the box addressed to 1200. And that's one of the problems. The only cardinal rule that you have when installing peripheral devices on your TI is no two can simultaneously occupy the same communications register unit address. There are 16 CRU addresses. They range from 1000 up to 1F00. And you can have a device attached to each one of them. So if you have a 7-slot PE box, you can theoretically put a second one up, which I have done, fill that one up, and still have 2 slots left over. If you were to address one individual device at each address. In addition, there are also devices that don't require an address. They just take up a card slot. We'll talk about those a little bit later. But let's take a look and see what the TI does when you first crank it up. You turn on the PE box, then you turn on the console. The reason why? Because when you turn on the console, one of the first things the console does is go out and start pulling CRU addresses to see what's attached to it. You turn on the console first, and then the PE box, the console won't know there's anything out there. There was an article on one of the micropendiums that Southwest 99ers did about a problem with the Horizon RAM disk. It was corrupted and would lock up the console when they started it off. As part of the procedure, they said turn on the console, then the PE box. They didn't know why, but that's the reason. Because if you turn the console first, you won't know that the Horizon's out there and it won't lock up. So you can go ahead and do whatever you want to load the DSR. When it goes out and pulls these individual addresses, and it starts at 1100, not 1000. It starts pulling at 1100, goes up to 1F00, and then comes back and pulls 1000. There's a reason for that. But what it does when it goes out and pulls these addresses, it looks, first of all, if there's a device there. Second of all, is there an executable DSR there? If there is an executable DSR, it runs the program. That's why you have like the Horizon menu program. It goes ahead and executes and gets a nice little menu on the screen. The Digit 80 column card has a nice little startup power up, takes control of the console. You get the TI mode 80 column screen. The P-code card does the same thing. It takes control of the console. It's important to know where the devices first are addressed and if they have a power up. My system has Horizon RAM, or not Horizon RAM, Quest RAM disk in with a menu program. The system I was using at the time also had a Digit card. Digit has a power up, the Horizon has a power up. In order to get the Quest menu to appear and be executable, it had to reside after the Digit card. So it could reside at any address above 1400 or at 1000, which is always pulled last. When that was the case, what would happen is you'd go out and see the Digit, you'd get a brief glimpse of the TI99 screen, you would go back to 1000, get the Quest, and the menu would appear. If it were done the other way around, if for example, if the Quest were addressed at 1200, what you would see is a glimpse of the menu, and then you'd see the Digit screen. So you have to know if first of all, the device has a power up and where it resides. Okay? If you have any questions as we go on, feel free to ask. In the case of the SCSI card, the SCSI is addressed at 1200. If you have no other device there, the SCSI won't work. It will lock up your computer. When TI built the 99.4a system, they had some ideas in mind as to what they particularly wanted and what particular CRU address. 1000 is an unassigned address, but TI uses for test equipment. That's why it's pulled last. They want everything else powered up, and then the test equipment powered up so they could test everything. Okay, 1100 is the disk controllers, TI, Core Comp, and MyArc. And while we're talking about disk controllers, let's talk about the three of them. TI disk controller first of all. TI disk controller is capable at the most of controlling 3 disk drives, double-sided, single density. MyArc and Core Comp will control 4 double-sided double density. I think MyArc will probably do 3 double-sided double density. The Core Comp card has a problem. It had the original. If you have an unmodified Core Comp card, it has a power-up routine, which means it gets control of the unit, of the computer first. Those graphics came out with a set of EEPROMs that did away with the power-up and also cleaned up some other problems that the card had. The 1200 TI originally spec'd that for an internal motor. That's unassigned right now. 1300. That is your RS-232 card. First RS-232. There are probably 3 main RS-232 cards. TI RS-232. TI RS-232 will work with most any other card that you want to put in the box. No problems at all with it. The only problem is if you ever have to modify the DSR, the chip is soldered in. You have to cut it out and desolder it and put a socket in. That's what you have to do if you're using a phone card, particularly the Digit. It uses a shared interrupt line coming in from outside. If you use it unmodified, it'll print about 1 page of stuff on the internet and lock up because it's confused with Windows. The Core Comp RS-232 card. It also will work with most anything except an unmodified Core Comp disk controller. For some reason they don't get along. The DSR chip is socketed. If you have to modify it, it's easy to take out, just pop a new one in. Then you have the MyArc RS-232. The MyArc RS-232, folks, is dangerous. It's not buffered. It does not have any 244 or 245 chips in it. If it goes out to lunch, it's going to take something else with it. Usually a bunch of stuff. If it blows up, it'll blow up most anything in the box. Also, I have 3 of them, and on 2 of the RS-232 cards by MyArc, instead of using a wire link, they use a solder bridge. Very sloppy manufacture on the original card. On the flip side, the DSR is socketed. It'll pop in and pop out. It's a simple transplant. If you want to use it with a Digit, take your chances. If you want to modify the DSR, that's possible. 1400 is unassigned. That's generally where the column cards reside. Digit, mechatronics, those things reside at 1400. 1500 is unassigned, but it can be used for a second RS-232 card. The TI RS-232 is a simple modification. You take a resistor, move it down 1 set of volts, and it becomes RS-232 number 2. It will acknowledge as PIO2, RS-232 ports 3 and 4. Well, theoretically, if you go to DSR, you could have 6 other RS-232 cards in there. Because you can't put a card in every address that you don't have anything or is unassigned. 1600, I believe, is unassigned. 1700 is what TI spec for the Hex Plus peripherals. 1800 is reserved for the TI thermal printer. 1900 is reserved for the EEPROMer. 1A00, 1B00 are unassigned. 1C00 is reserved for TI video processor card. 1D00 is reserved for the IEEE 488 controller. 1E00 is unassigned, and 1F00 is where the P-code card resides. And that's P-code card is the only TI card with a power-up routine. So when TI designed the system, they wanted all this stuff, and none of the others had a power-up routine. They wanted the P-code card last, except for the test equipment. So they put the P-code card in 1F00 and left 1000 unassigned and used their test equipment there and put it in last. So what it boils down to is when you get ready to put a system together, if you're using a standard system, 32K card does not take an address. They put a disk controller in there at 1100, put an RS-232 in at 1300, you've got no problems, they all have different addresses. The problem occurs when you start to expand beyond the basic system. Now, there are several cards that do require a CRU address. We mentioned a couple of them. The digit is one, it goes to 1400. If you have something there, it has to be moved. One of them has to move. And the digit is a fixed address, so it's not moving, something else has to. Quest RAM disks, when they first came out, were hard-coded by PAL and jumper block at 1000, 1400, and 1600. Two of those addresses are unassigned, and one is occupied by an 80-column card. I ended up with 3 Quest cards and got greedy, wanted an 80-column card. I said, something's got to give here, because I can't use 1400 for the Quest. So I embarked on the Quest project. First thing I did was get a copy of the PAL code for the PAL that controls the DSR addresses. Sent it off to Don Walden with instructions to go ahead and reprogram it for 1800, 1C00, and 1E00. So by using the same jumper pins, I can have another PAL in the card, move the jumper, and it would answer at 1800, for example. That freed up 1400 to put a digit card. Okay, well, then I got an AMS card. The AMS card is fine if you just use it as a 32K. But if you want to turn on the mapper, it's at 1E00. So there's another conflict with the last address on the Quest. When the Quest manager program booted up, you would go and pull 1800, fine, pull 1C00, fine, we'll pull 1E00, turn on the mapper and the AMS card and lock up. So back to the drawing board, get another set of PAL chips burned that would address 1200, 1800, and 1C00, just leave 1E00. That in turn, I had to go ahead and do some work on the manager program. Bruce Harrison and I collaborated. And now, with the proper PAL chip, the Quest card will reside at any even address from 1000 to 1C00. You can have theoretically as many as 7 Quest cards in one system. That's 3.5 megs. There are other cards that require CRU addresses. Verizon RAM disk is probably the main RAM disk right now. The addresses are selectable from 1000 to 1700 by dip switch. You just turn whichever address on you want. You just have to be careful that you don't turn on the address when something else is. The P-gram card, Tony has a P-gram card, is quite familiar with it. It will also occupy any address from 1000 to 1700. Seems to be good until 1700 for some reason. My 512K memory card is unique. It occupies 2 addresses, 1000 and 1400 if you partition. Triple Tech card is at 1D00. The Foundation card, the 28K card, is at 1E00. The AMS card is also 1E00. If I had a choice, I'd choose the AMS, particularly with the 512K RAM chips at $19 a piece. You have a 1 meg AMS for about $40. Some of the new German cards, the high-speed GSL card, the HSGPL card, is addressed at 1V00. The CPU card you have that goes with it is at 1E00. Those addresses are not changeable. So they're mutually exclusive, but the SG CPU card may emulate the AMS card. So you don't use the AMS card as a substitute for it. There are also cards that occupy a slot in the P box that you might have to worry about a CRU address. 32K is one. The speech synthesizer card by Rave that goes into the box just plugs in there. The MVP clock card doesn't require an address. The MVP clock card also has an analog to digital conversion circuit on it, which means you can use it to, they use it for weather station, wind speed, temperature. You can put a couple of simple contacts on it, use it for a burglar alarm, all sorts of things. The only requirement is that the input cannot exceed 5 volts. Going back to disk controllers for a minute, a lot of people, but some people with these new 3.5-inch disk drives would love to hook one up. It's not too difficult. There have been a couple articles in Micropinion how to hook a 3.5-inch disk drive up to TI. Most of the 3.5s will only access either drive 1 or drive 2. You don't have the big jumper block that you can select, like on the old 5 1/4 where DS0 is DSK1 and so forth on up to probably 4. So what you have to do is you have to make a specialized cable. And if you're blind out of one eye and can't see out of the other like I am, then somebody do it for you. You're kind of turning there into it. And what you basically do, you just have to, starting from the pin number 1 on the cable, pin number 1 on the cable will have a little red line going down on one side. You count in when you get to 12, from 11 to 12 you make a slit. In between 14 and 15 you make a slit. Take the cable, twist it over, and crimp an end on it. What that does is that swaps pin 12, which is DSK2, and pin 14, which is DSK3. So what you end up doing is the controller is, I'll turn on DSK2, but it's really turning on DSK3, which happens to be the 3.5-inch disk drive. It's not a difficult modification to make, if you can see.
Sort of like a high-speed lane change, huh?
Yeah.
Frequent.
Yeah. There are a lot of things that you can add to the TI. Well, let's talk about some of the cards that have what is Dan Eicher calls them system anomalies. I call them P-box personality aberrations. A digit card, 80 columns, great, works just wonderful in 80 columns. Takes it about 30 seconds to warm them up. Everybody I know that has had a digit card takes it about 30 seconds to get warmed up. You can't just go in and pop, and you're in the funnel. You can, but you get a partial load of the column over. Also, I found it does some unspeakable things to cards addressed at 1,000, particularly RAM disks. If you have a RAM disk at 1,000, you better have it write protected. I had a Quest at 1,000. With my digit turned on, usually I'd go ahead and save a program to it, go ahead and write protected and then exit. One time I forgot to write protected, exited, booted back up, and the digit ate the Quest. Ate it for breakfast. Just wipe the DSR off so I don't remove it. Another thing the digit does not like is a cartridge plugged into the cartridge port. One problem I've encountered with it is that if you try to run archiving with a standard extended basic cartridge in the cartridge slot, you get a character set that looks like Chinese. Tony's had problems with his printing out the parallel port. It just may be the, I have no idea, I have not had that problem with mine. But cards do have aberrations. The foundation card is a particularly nasty beast. I don't know what it does, but it likes to eat cards for breakfast. It'll go ahead and even though it has nothing to do with where it resides in the box. If you have problems with your P-box system and you have a Foundation 128 card in it, pull it out and see if things work then. Let's see, there's some other ones, like I said, the core comp cards can't seem to get along unmodified. This controller and the RS-232 don't like each other. The AMS card, if you're just using it as a 32K, I don't know why anybody would, but if you never turn the mapper on, it does not need a CRU address. And why you go ahead and go to the expense of buying a 256 or one-way card, just use it for 32K as well. Like I said, when you set up your system, make sure you know where everything is. And the example, you know, where you have the go and buy your SCSI card, stick it in the box, and then get this big cyan blue screen and nothing happens, and you forgot to put your horizon there. You gotta move your horizon because it's SCSI can't move. Or if you go ahead and, like I said, if you have the menu screen that you want to boot the boot up menu in the wrong place, you're going to have to change it because of the folding sequence. The system that I have, I'm running right now, Harry happened to have one of these Y cables for P-box. And what it is, it's a section of cable about 8 to 10 inches long. It's got a female connector in the middle, 2 male connectors on the end. The female connector pushes into the side of the P-box. 2 male end connectors push into the individual arms of the individual P-box cables. That enables you to have a second P-box. I've got 4 West Ram discs, a Horizon, an AMS, 2 RS-232s, an MVP clock card, TI disc controller, spread over 2 boxes. That's all it can be done. Another way to expand the P-box is to go ahead and run a cable from the first one, the last slot in the first one, to the first slot in the second one. You don't need a bridge card. You run everything straight through except for the power lines. You get the pin out, I think it's the last 4 of the first 3 lines, your power. You don't want to connect those. You don't need a bridge card in the second box, but you still end up losing the slot because of the cable coming in. Whenever you're doing any of this cabling, try to keep the cables as short as possible. You can daisy chain P-boxes that way. All the new cards coming out, there's a new one coming out from the German group, EVPC card, which is supposed to be an elevated column card. Michael Becker's been up on the list server talking about it. There are 2 versions, one with a 9938 chip, which is an 80 column chip with a mouse port, and one with a 9958 chip without a mouse port. And it'll be interesting to see if he can overcome the problems that the other 80 column cards have.
You have a price for that, you know?
He was dickering about a price. I think everybody was talking about somewhere around the $200 range.
Yeah, he was saying it was going to be very expensive if they started asking about prices. And finally somebody kind of pinned him down. He said, well, from 150 or a little above that maybe.
Yeah, that's not particularly expensive considering it's a digital for 230 lumens.
Right, it's got all that in it.
Then they've got a mechatronics 80 column.
Yeah, there's one for $85 out there, mechatronics 80 column.
By the way, that German made one is some of the prettiest workmanship in engineering I've ever looked at.
It'll be interesting to see if he can overcome the problems that the vision card has. I don't know that you can, or I don't know if it's possible, but I sent him a message and said I'm interested in the 9958 card because the Digit, in addition to the other problems, uses some areas to store code. I happen to have a Horizon mouse, and I can't use it in Extended Basic because the code is the same place. The end result that I took was to take the Digit card, put it in a box, set it on the shelf, go back to 40 columns, And you may have to do this from time to time with some of the cars. When you're talking about expanding your system, decide what you would like in your system. Figure out if you want 80 columns. It's free. It runs FunnelWeb 80 column editor with you can process several files at the same time in memory with a circular buffer. But is it worth that in the graphics to give up, in my case, the granulator, the Horizon mouse, and some other things?
No.
Well, so you've got to figure out what the trade-off is between what you want and what you're able to do.
But your phone writer, chances are you're going to run into an IBM brand anyway or something of the kind.
FunnelWeb runs just fine.
Yeah.
In 40 columns, and it has about 90% of the same features the 80 column version has.
Mm-hmm. And then when you put it in any of the editors on IBM type, it's just, you can make it 80 column or any number you want almost immediately.
Sure.
So,
And for those of you with an AMS card, like I said, Bruce and I collaborated and came up with an AMS test program, version 4, which will test any AMS card up to a meg. Bruce has it out there. If you want a copy of it, I think he'll let you copy it. It'll come with the source code. It also has a sort program on there that Bruce put in micropentium. I ended up modifying and changing. There are two versions of that, one of which runs completely within FunnelWeb. Uses 19K of the 24K memory expansion for text cells. The other version is a standalone that uses the entire 24K. And those are also available. I think Bud Mills is here with Horizon. Ross 8.14F is the latest version. It does not have the iGotcha in there. It works fine. Talking about, I think there's some MyArc gear out there. I think I saw a MyArc disk controller. MyArc disk controller also has a problem with boot tracking. It doesn't store the last drive access in the same place as the other two, so you have boot tracking problems with it. And that's why with FunnelWeb and some of the other programs, they have a flag that they will set if you have a MyArc. They'll ask if you have a MyArc, or if you have a MyArc, you have to modify this and modify that, so it knows where to go look for the boot drive. But, there are all sorts of things, all sorts of ways that you expand your TI. Most of the problems occur, like I said, ignore the only rule: the two devices can occupy the same CRU address. Anybody have any questions?
Just go on, when you got the two key boxes hooked up like that, can you use 4 disk drives, 2 on each one?
No. If you have a core comp card, you can.
Oh, okay, but you could.
Theoretically, somebody says, why can't, if you have one disk controller in there, why can't you put another one in and have 2 more drives? Well, you could if they occupy different CRU addresses.
Oh, that's right. 1100.
But the disk controller will occupy 1100. They're always 1100. If you could theoretically write a DSR for a disk controller, let's say 1900, it would operate at 1900, it would work fine. The Quest card, for example, when you go ahead and use a Quest card and designate it as drives 4, 5, 6, 7, 8, 9, which I've done with mine, then the Horizons is A, B, C, D, E, F, and G, each have their own DSR, and what it does is it goes out there and looks, and it thinks that that's a disk controller and a disk drive out there, and there it is. Just like with the RS-232 cards. Some guy in Australia has come up with a way to have, in essence, 3 of them, 6 serial ports and 3 parallel ports. And if you're using more than one RS-232 card, which can be a good idea, I've got 2 printers at home. One's one of the old TI impact printers, and I'm going to hook that up to my second car, change all the designations in my label program for PIA/2, just stuff labels in, use that for just registering labels, instead of using a AB switch box. Because it takes probably 30 seconds with a desoldering iron and soldering iron to change an TIR-232 from one to the other. Like I said, several articles in Microphenny about that too, just revolves moving the resistor.
Speaking of the core comp controllers, I think all of them eventually become flaky. They'll see a drive part of the time and not part of the time and all that. And it'll continue to get worse until they don't see it at all.
In the December 1996 Microphenny, I had a core comp that's now under repair. There was an article in there that had a list of all the core comp products and the problems that they had. Core comp disc controller, there's a variable resistor that needs to be tuned. There's also, I think, a resistor needs to go from the 127 chip. Some of the disc controller chips I used in there were flaky.
People told me to change the, what is it, TMS99 or?
That's not the problem. The problem is a disc controller chip and reads a resistor. If you have the December 96 Microphenny, there's an article.
I can find it.
It goes in there and it talks about the clock card. One of the problems there is in some of them they put a resistor instead of a diode in the charging circuit, so the lithium battery is prone to blow up. There's some other problems. They go through all the core cards. Incidentally, the Triple Tech card, I'm told reliably by somebody that if everything goes out to lunch except for the clock card, it doesn't use the CRU address anymore. But the buffer and what's the other function? Printer buffer.
My printer buffer died and the clock died. So I pulled those two chips out and it works great in the speech part.
Okay. The speech part, well, I would assume that except for the printer buffer, it will work fine as a clock too, because that should not take a CRU address. And I noticed out there too, if you're looking for stuff, that Larry Connor has some blank MVP clock cards. I think maybe one of them's got a clock chip in it, the other ones are socketed and ready to go. All you gotta do is buy the chip and stick it. $15. If you like being your collector, go out there and get the artifacts and expand.
You have to have a clock and you'd like a few good things to go with it. That's T-Gram Plus behind that.
Yeah, it is.
You can work that clock with SPT or core comp clock you can work.
Triple Tech and the T-Gram card respond to clock. You can go ahead and access them by clock. The MVP does not. There's still some programs out there, disc catalog programs and everything else that will print the day and month and so forth. It's interesting to note that these clock cards, there's been a big discussion on the listserv about the year 2000 of the TI. It doesn't exist except for the Janine. And I think that was fixed. I think Tim Tesh fixed that. But for example, the MVP clock card, it doesn't even access the year. It accesses the time, minutes, hours, seconds, and so forth, the day and the month. It doesn't access the year. That's entered when you first configure it in the extended basic program. If you haven't done so already, change it to 1985, please, in the current year. It'll give you the current year. If you're using Remind Me, which is a nice little calendar program for you, a daily reminder calendar program, it gets the year in that program from the configure part of the program. Just enter the year and it'll show you in there 3006. As far as it was concerned, the year 2006. But the TI, except for the GE, now there is no problem with the GE. It doesn't have a problem. If you have a RAM device, cartridges like personal records keeper, they'll go till 1999. You can go in there with a RAM device and change the 19 to 20 until it becomes 2000, and you're ready to go from there. So it's not the big program, the big problem that the IBMs have, the software reverts to 1900. Any questions from anybody?
No, thanks a lot, Bob. That's super good talk you gave. One question, once it has pulled all the devices, does it get a device name as well from that device?
Not as such. It knows there's a device out there that say 1100. And it depends on where the device name is in the DSR. For example, if you want to pull and look for a digit card, you have to search for a string. If you read the docs, it says to search for a string digit and it displays that it's a digit card. A good way to look at that is if you have a Verizon ROS 8.14F and you run the configure program, anything that does not have the name of the DSR, the name of the device, and the spot that it is looking for comes up as an unknown target. Quest comes up as an unknown target, or several others, but it will find TI RS-332, will find TI disk controller, and show that that's a TI disk controller. The TI does virtually the same thing, same type of controller. So it may or may not get the device depending on the DSR, how the DSR is, and what the device name is in the DSR. The folks got done?